Welcome to the day 2 of the International Systems Unity in Fair Digital Data Conference of BIPM. Today we have a long session with 2 parts. The first one is we presented with Mr. Alfonso Carrion, and after the presenters, the record presenter being aired, we are going to have 15 minutes of discussion with the questions of the audience. You have to put your questions, for the ones who didn't come yesterday, on the chat, and after the session we are going to discuss the questions. We are going now to present the speakers of this day 2. We have two agenda. The topic 1 is global data science, and the topic 2 is international quality infrastructure. At the end of the first one, there will be a break period. The system is offline, and you have to enter again to the second session. So let's start this session today. We will have for speakers, first Simon Cox of the conference, Digital Units of Measurement Services, Communities Coverage and Alignment. Mr. Cox works on practice and standards for the publication, transfer of science data, particularly geospatial.
Hello, I'm Simon Cox from CSIRO, which is Australia's National Applied Research Organisation. My presentation is on digital units of measure services, communities, coverage, and alignment. So here's an outline of what I'll be telling you about today. I'll be introducing and reviewing a number of existing digital units of measure systems. Why is there more than one? Well, this is related to their origins in different communities and different applications who have different interests and scope. Also, there have been a few different technologies and different levels of adoption, both within and outside the originating community. Finally, I'll make some comments on the potential for harmonization and what is already going on in alignments. Why is this relevant to digital SI? Well, I guess this should be obvious, but just in case, SI is just a subset of all the units of measure that are in use. It is the most important rational subset and is almost always used as the bridge between other systems, such that pretty much all other systems of units, even in the US now, are now defined as scaled versions of SI. There are also many existing digital machine-readable units of measure representations. To understand if we can make use of them, we need first to understand a bit about their scope and technology, and importantly, where they come from, which applications and communities built them. I'm going to describe 3 systems in detail and then summarize several more. First off, the Unified Code for Units of Measure, or Ucom. Ucom is an implementation of and direct successor to a series of standards that aimed to define codes for units of measure that, on the one hand, look like the usual scientific codes, but on the other hand, can be typed on a standard keyboard. Some of you will recognize the names of the predecessors. None of these was complete or fully consistent, so starting in 1998, Ucom has attempted to rationalize them. It is primarily the work of 2 heroic souls, Gunter Shadow and Clem MacDonald, and is formally owned by the Regenstrief Institute, which, despite its odd name, is part of the US National Library of Medicine. Here's the summary of what Ucom does. Note that the symbols that are not available on a standard keyboard are approximated. The base symbols can be combined with prefixes for compound or multiple units, for example, decagray and femtomole, milliliter, centimeter, or by multiplying or dividing them or raising them to integer powers for derived units. Non-SI terminals are also available, for example, colony forming units, percent, gray. Qualifier suffixes are in square brackets, for example, centimeters of mercury, and annotation suffixes, which don't actually change the values, the conversion factors, are in braces, e.g., for example, percent volume. The definitions table includes the conversion factor 2SI for each atom, which allows any quantity scaled with a valid Ucom code to be converted. The formal definition of Ucom is a Backus-Naur production rule, which can be implemented using the finite state machine shown on the right. The Ucom dataset is an XML document. You can see the small amount of detail required for each definition here. As I mentioned previously, Ucom comes from the health and clinical medicine application space. Ucom is built into HL7's FHIR system, which is widely used in clinical settings. There are also some validation and quantities conversion services available. There I've shown both the user interface and the service descriptions. Ucom is considered essentially complete, but there is a public maintenance process managed through a track ticketing system. Fixes and enhancements are still occasionally made, but note that because Ucom defines a generative algorithm for derived units, it does not require an update or new release just to add a new derived unit code, which only uses existing atoms. Next, the QUDT, Quantities, Units, Dimensions and Types system, originally from NASA and Top Quadrant. QUDT actually came about following the issues with units that contributed to the Mars lander accident. QUDT now has its own organization, though Top Quadrant still supports it. The QUDT model links units to quantity kinds to give the semantics and dimension vectors to give the physics, if you like, within the systems. This diagram is just to give a sense of the level of detail that is supported by QUDT, as it also includes recording the symbols and codes from various symbol systems, including LaTeX, UNECE, and Ucom, and also offsets and multipliers relative to SI required for conversions. QUDT publishes a series of collections, one for each type from the model. So there is a set of quantity kinds, a set of dimension vectors, and a set of actual units, as well as these other pieces. Here's the top of the units catalog, showing the A's. Symbols like unit : A-per-M are shorthand for URIs, which are persistent web identifiers. The actual URI for that unit I just read out is shown at the top of this example entry, and the whole entry shows the detail available for each entry, including the Ucom code. QUDT is implemented in OWL2 and also in Shackle. Maintenance is tracked in a public GitHub repository. New releases occur approximately monthly, typically with 1 to 10 new units, plus other fixes. QUDT came from engineering applications and has been adopted in a number of engineering and manufacturing contexts, as well as some science areas. The Nerc vocabulary service includes one collection of units of measure, known as P06. The Nerc vocabulary service, or NVS, is a big vocabulary service which is an important part of the marine science and oceanography infrastructure. The oceans community tends to be quite good at establishing and maintaining shared infrastructure, probably because their kit is big and expensive, therefore usually shared. We're talking about ships and global constellations of sensor platforms. NVS has around 300 separate vocabularies, of which P06 is just one. Some of these vocabularies are very large. For example, the notorious P01 has around 50,000 terms in it. P06 is essentially an inventory of units that are used in actual data sets. It is not designed to be fundamental or comprehensive, so there are sometimes surprising omissions. For example, P06 includes knots, nautical miles per hour, but nautical miles is not there because no data sets measure distance in nautical miles. Here is one of the entries from P06. A key point here is that it is not a fully structured unit definition, just a name, identifier, and textual description, together with a large set of links to related terms in other NVS vocabularies, mostly to terms in the Observable Properties inventory, that is the quantity kinds that use this unit. The simplicity of the representation is because this collection of terms is formalized in SCOS. SCOS is the standard formalization of all the definitions of NVS. And here's the SCOS serialization of becquerels per kilogram. Note that there is also a link to the QUDT definition, so a formal structured definition could be got to from here. As mentioned, NVS comes from the international marine science and oceanography community. It is comprehensively used in operational systems within that community, particularly by the European members. But NVS is also used as a reference point for definitions by the entire international Earth and environment science community. So that was an overview of 3 of the key systems for digital representation of units of measurement. Each of the ones I showed has got quite a long heritage and also significant adoption and implementation in one or other community. Ucom in health and clinical medicine, particularly in HL7 fire, QUDT in engineering and science, and NVS P06 in marine science and oceanography. However, there are a few other systems that are worth mentioning. OM, UO, and Suite are all OWL ontologies. They come from science communities. While they're not necessarily implemented in operational systems, they are the basis of a lot of analysis and investigation amongst ontologists and in experimental systems supporting science data. OM is hosted at Wageningen. UO is part of the Open Biomedical Ontologies, or OBO Foundry. And Suite was originally also developed at NASA, but is now maintained by the Earth Science Information Partners, which is funded through NASA, NOAA, and the USGS. Moving on to a bit of analysis and consideration of why so many, and is there anything to be done about it? First, some statistics. Here I've just counted the number of units in each system, plus a few other types where I think they are interesting. Ucom is in principle the most parsimonious, as it only has the unit atoms that can then be combined to build an unlimited set of derived units, but there are still 310 entries. QUDT is the biggest in this survey at 1,700. However, 350 of these units are either currencies, oh dear, or multiples or submultiples of simple units. QUDT also has substantial catalogues of more than 800 quantity kinds and around 200 dimension vectors. OM has almost as many units as QUDT with more than 1,400, but as well as currencies, yikes again, it also includes a lot more multiples and submultiples, since it exhaustively enumerates all the petas and yotas and attos and femtos and yoctos of many basic units, even though they would rarely, if ever, be seen or used. Suite is just an inventory of 138 units that the editors had come across in Earth Science. And similarly, P06 is an inventory of 375 units that appear in marine data sets. Finally, UO is a set of 597 units from biomedicine. Surely these could be replaced by one system. Well, yes, the theory to describe a unit of measurement is straightforward, and the models show the same classes, sometimes with slightly different names, but are easy to transform. However, the prospect of harmonization to a single system, I don't see that as practical or necessarily even desirable to imagine that the systems can be replaced anytime soon. Some of them are built into big operational systems with a significant investment, and they work well enough, so why would the operators replace them? However, there is definitely no need for any new systems, so we need to advertise the existence of these. And as long as we can keep the numbers down, fewer than 10, say, then one-to-one mappings between them can probably be maintained. And there has been some progress on alignment. There are now mappings from all of the systems to Ucom and from several of them to QUDT. I've been involved in building many of these mappings. The rationale for using Ucom and QUDT as the core for alignments is that the Ucom codes are unique textual identifiers, so can be used as keys for joins. And QUDT, having a full semantic model, able to describe derived units as well as the fundamental ones, and is also the most responsive to update requests. Adding a new unit, or addition of a new unit, can be processed in a few days, and there is a formal release of QUDT round about monthly. So what have I told you? There are a number of existing systems for digital descriptions of units of measurement with various levels of modeling and formality. Most of these are potentially fully general, though the exact inventory and implementation in each are grounded in a specific community. Ucom being purely generative, while the others each persist an essentially arbitrary suite of derived units representing an inventory of units used in a suite of applications within the specified community. There are some alignment efforts underway, primarily based on using Ucom as the textual key and QUDT for rapid publication of U units for bridging purposes. I think that's probably enough for now. I'm done. Thank you.
Hello, my name is Eric Schultes. I'm the FAIR Implementation Coordinator at the Go FAIR Foundation here in Leiden, the Netherlands. And I'm very happy to be with you today at the FAIR Systems of Units conference and workshop. And I would like to tell you today about recent work we've done on making fair metadata and making it easy for people to make fair metadata. And our interest in incorporating fair SI into the work that we're doing. And this is, by the way, all in the context of the Dutch COVID-19 research program. So this is really work that's been built up in a very urgent way over the last year. And so I'll try and take you through that process and see how we are trying to focus in on fair system of units. And before we get into the details, I want to certainly acknowledge the hard work and the great efforts of a team of people that are working to create an easy pathway for domain experts to create the metadata that they need to express their data in increasingly fair ways. And I want to highlight in particular the work of Barbara and Nicola, whose work I will draw on pretty heavily in this presentation. And I also wanted to mention that the work that I'm presenting, although very focused in a use case on COVID-19 in a Dutch setting, is actually part of a much larger verification framework. And I won't go into details on this today, but I have a link here so you can see that the things we're trying to do with metadata actually fit into a larger verification framework. So let's begin with the COVID-19 data portal project. So this is a national research program in the Netherlands, launched in urgency with lightning speed to research and make progress on COVID-19 related issues. There's two notable characteristics about this funding program that are quite extraordinary, quite innovative. The first is that there's a mandate within the ZonMV research program that research outputs are to be made fair. So that's a pretty strong mandate, but it's backed up by, number two, the support for fair data stewardship, both at the level of the PI. So that's this, I mentioned here, this 5% discretionary budget available to the PI for fair data stewardship issues. But then there's a larger project in the background that's working to create tools and services and methods that enable fair data stewardship. And I have a quotation here by Margreet Bloemer, who's the architect of this COVID-19 research program. And so to get into the content here, it's very nice to focus at the beginning on the FAIR principles themselves. And what you see immediately when you look at the principles is that metadata is everywhere. And I think the FAIR principles have done a great job elevating the idea of metadata to be really a first-class citizen with the data itself. And just in December, both Mark Wilkinson and Mark Mewson had independently mentioned to me that FAIR is 90% metadata. And so I asked them if I could use this quote, and they said, sure, go ahead. So from these experts, we can see that metadata is in fact gonna take us a long way down the road to fairness. I also wanted to highlight principle R 1.3, which asks us to focus on domain relevant community standards for both data and metadata. And this is what really inspired and took us into this idea of metadata for machine workshops. Because although domain experts are required to create their domain relevant community standards, in most domains, most experts are probably not experts themselves in metadata, and maybe not, or certainly not in most cases, are they experts in machine actionable metadata. So the metadata for machine workshop idea was to say, well, if we want increasingly for domain experts to use and to create fair metadata, then we probably need to team them up with experts in fair metadata. And in a kind of hackathon environment, they could be able to produce the vocabularies and the metadata schema that are required to to lift their data assets to a very high level of fairness. And what that means is that these metadata components are themselves fair at a technical level, that they fulfill the domain-specific requirements. And we know that's the case because we have the domain expert in the workshop, and that these outputs, these vocabularies and metadata schema are themselves reusable. And we think if that's the case, if these three conditions hold, then we should be able to see the creation and then the widespread adoption and reuse of useful, fair metadata components. And in this workshop environment over the last couple of years, we've drawn on several different tooling and research groups that have been working to perfect methods in fair metadata. And I'll show how that looks in the presentation. And what I want to mention today is that we'd like to try and get to fair SI units as a part of our work in metadata for machine workshops. And for this, we're looking at the moment at the QDT standards, and I'll show you how that looks. So the metadata for machine workshops that we launched for the ZoneMV COVID program began last September, October, and it was really in November that we launched 6 metadata for machine workshops. We distributed the 62 research projects in the COVID program over these workshops. And you can see them listed there in terms of the number of people, number of projects. And in each case, in these workshops in November, we had the research domain experts and a data steward help us brainstorm on what we call project assets. So anything related to the project that needed to be described by metadata, such as data, biomaterials, services, standards, we went through very controlled, very structured brainstorm sessions using a tool called Padlet. This was all done online, of course. And what this allowed us to do is pull out of the domain expert the preferred terminologies that describe their research assets. And now what we've done in February is we've run an additional couple of workshops where we've been able to consolidate that list of terminologies, and we've begun building a formal vocabulary that describes these things. And in this, we've been linking to the existing vocabularies in BioPortal, ontology repository, and we've been using tooling that we've developed in what's called the FAIR Data Collective. And the ultimate goal here is to produce a COVID-19 research program vocabulary agreed upon by all 62 research projects, and that vocabulary would be available then for the CDAR workbench, which is a very nice tool that allows you to compose metadata templates in kind of a modular format. And then these templates become shareable as simple web forms or through APIs. And then either machines or humans can populate these templates and create metadata instances for different data sets, for different projects, et cetera. And what we will ask the data stewards in the COVID program, our Dutch data stewards, we will ask them to work closely in support of the researchers to help get these forms more and more routinely filled in, and thus creating metadata assets for the research project. And these metadata and the data themselves will then be put onto a network of fair data points and made available in a fair way. That's the COVID-19 research program, and this is some of the tooling we're using to try and create reusable metadata components. And I just want to mention, though, that above and beyond this one instance of COVID-19 research for ZoneMV, there are other metadata for machine workshops that we're running, some of them COVID related. And so you can begin to see that there should be automatically now a great deal of overlap that we can reuse vocabulary and templates from previous metadata for machine workshops. But it may be surprising for some that we can even reuse quite heavily components that are created in completely different domains. So for example, with the Danish group, we've run metadata for machine workshops 5 and 6 based on wind energy data sets. And in fact, we are repurposing quite heavily from wind energy domain in the COVID domain. But this is all in an effort to try and to get reusable metadata components and to not have to reinvent the wheel each time. And by using these components, we can better guarantee interoperability and fairness. So coming back then to these metadata templates that we created as part of the COVID-19 program during November and February, there's really 3 templates here that we have. We call it at the top, you see the project administrative metadata template. In the middle is the project content metadata template. And at the bottom is the generic dataset metadata template. These are links to the templates themselves. As you can imagine, the project admin metadata is just very high level. I think there's 22 fields that are requesting very basic information about the project. So the PIs, the funding agency, the grant number, et cetera. The content metadata template in the middle is starting to give an overview of the scientific content of the research project itself, but again, at a very high level. But that project content metadata could point to data set metadata so that we have a quite extensive template for any data set that might be created in the course of these research projects. And I want to zoom in on this on the generic dataset metadata template. And you can see for yourself at this link at the top at OpenView. But you can see here a bunch of fields. I think there's 90 fields total, although a very small number like 10 or 12 are required. But you can see these are general types of fields that can describe and be applicable to any kind of data set. And I want to highlight then this one particular field called variable. And this is a very modular component of the metadata template that basically asks, what did you measure? Describe that measurement you made. And although we have a model behind this now, it's very straightforward, very simple. As the iAdopt group at RDA finishes its work on creating a more elaborate data model for what they call observable properties, we will almost certainly be using this as well. Here's a deeper view of the iAdopt observable properties. And so what you can see is that the observable property, so the thing that you're measuring, can be characterized by observed object, observed property of that object. And there's modifiers, including measurements and units and units of measure. And we will be extending, or let's say adopting vocabularies for this model from the QDT unit and QDT quantity kind vocabulary. And so here's an example of a generic dataset metadata template. This is a CDAR template. In this case, this is for a COVID-related measurement, like average physical exercise duration per day. We are observing time. This is for physical exercise for humans. This is measured per day. We're looking at the average, and our unit of measure is an hour. And we will take that unit of measure description from the QDT vocabulary. And so what you can see then is that this CDAR form is going to contain within it drop-down menus that allow the researcher to be able to select from fair or verified units of measure in a very direct way, helping to structure and make machine readable the metadata that's being input. Here's some other observable properties in the COVID program that we've procured from our data stewards. And the hope here is that we will be able to embed in these CDAR metadata templates QDT units for a range of different measurements like concentration of virus and saliva, blood pressure readings, weight, length, body mass index, etc. And once we have these templates, then the exciting part is that we are able to then repurpose these templates and the vocabularies that they're using for other projects and other research domains. And so, for example, the Wellcome Trust and ZoneMV are now committing to the next generation of metadata for machine workshops, not only in the COVID space, but in other biomedical and research domains. This is also true for the Danish E-Infrastructure Corporation. There's a metadata for machine workshop in April on bioimaging. We will have another workshop later in the spring on carbon credit technology. And then the Health Research Board of Ireland is also now more interested in running a metadata for machine workshop for COVID-related topics. And the idea here is that what we would like to do is have reusable metadata templates that are using these FAIR units of measure, and that are becoming more and more mandated in their use by the funding agencies themselves. And we hope that this combination of these CDAR templates with the funders in these research projects will help to further the uptake and the widespread use of FAIR system of units in the future. Thank you.
Hi, I'm Sarah Jones from Géant, and I've been asked to speak to you about the EOSC Interoperability Framework and how that's facilitating cross-domain discovery and reuse in the European context. So first off, I wanted to explain a little about what EOSC is. So EOSC stands for the European Open Science Cloud, and it's an initiative led by the European Commission, which is creating a web of FAIR data and services. So what we're doing is federating the different e-infrastructure and research infrastructures across Europe to provide an environment in which data can be brought together with all the services to perform the analysis and enable researchers to address societal challenges because they can get all the relevant data from the different spaces. So you can see in the visual on the right here, the basic kind of architecture of EOSC. We have a core set of services, so things around AAI, so authentication and access, around the persistent identifiers and metrics and help desk services. And then what we're doing is federating both data from different repositories and different communities. And we have this EOSC exchange layer where a range of other resources and services are brought together to enable researchers to choose those to act on those data sets. So the aim of EOSC is to enable multidisciplinary discovery and reuse. At the moment, we have a number of research clusters and infrastructures, and if researchers want to use data from other spaces, they'll need to consult with services and repositories in different areas and bring the data together manually. And the EOSC vision is to federate these disconnected silos so that we can have one environment in which researchers are able to find all the relevant data and then to act on that as well. And this is part of a broader vision. The EC is signing a number of European partnerships at the moment and investing in a number of data spaces. So in the areas of agricultural data, for example, or energy or the Green Deal. And EOSC is a horizontal that cuts across these, that's addressing all different research communities, and we're aligning with these different data spaces. So what I want to focus on in this presentation is the interoperability framework. This is something that's been developed through the current EOSC governance. There are a series of working groups that were established, and the architecture and the FAIR working groups came together to develop the interoperability framework. And you can see how this fits into that overall model of EOSC, and that it's really a layer to help us bring together all the different types of outputs, so not just data, but publications, software, and services, and to interoperate between those. The interoperability framework has FAIR at its core, so this is a key concept for EOSC. We want to make sure that all the objects within EOSC are fair, that we can discover them, we understand the permissions that are assigned to those, and they're conforming to community standards so that we're able to reuse. So this is a kind of core premise that runs through the interoperability framework. The main report has been published and is now available on the EC's portal. And you've got the DOI there, so you can go and download that. And there are a couple of additional files that we made available. One of the things that came back when we consulted on the initial recommendations was the need to develop a reference architecture. Now, the group that was doing this was, a volunteer group. It was through a working group that people were committing resource to, through their own organizations. So some preliminary work has been done here to do a basic reference architecture around the digital object framework. So looking at fair digital objects and what's needed for implementation of those. This needs to be extended, and it also needs to address the service angle. We also started a preliminary metadata mapping where we looked at the different kind of standards that are in place across the communities and the key standards for resource discovery. And I've done a mapping between those to start to think about a kind of minimal metadata model that can be used within EOSC. So within the interoperability framework, there are 4 layers that are addressed. And this takes its idea from the European Interoperability Framework, which was used for public resources. And it applies them to EOSC. So we address the legal interoperability, so thinking about the different legislative contexts in each of the member states and associated countries, and addressing issues of copyright and data protection and GDPR, and how we align those when there are differences across the different contexts. There's also a strong focus on licensing. Licenses are clearly critical for all of the digital objects, so we know who has permission to use those and under what restrictions. We then address organizational interoperability. So this is looking at aspects of governance and also the rules of participation. There are a set of rules of participation for EOSC at large that look at the requirements for the different service providers and also for the different users. And then the aspects that I think are of more interest to the audience today are semantic interoperability and the technical interoperability. So with semantic interoperability, there's a strong focus here on metadata and ontologies naturally, and interpreting the meaning of these, so understanding when people are using common terms, whether they do in fact mean the same thing or if those terms are used in a different way in different contexts. With the technical interoperability, this is looking at the infrastructure at large and how we can interoperate between the different technical building blocks. So to give you a few example recommendations, we are calling for open specifications for all EOS services so that we know the regulations on those services and we can understand those. We call for coarse-grained and fine-grained dataset and other research object search tools, so people can search for a general topic, or they could search for a specific gene, for example, and find the relevant content. In order to deliver this, we do need clear, publicly available definitions for all concepts, metadata, and data schema. And we're trying to define this minimum metadata model and crosswalks to ease discovery over the federated data. Now, beyond that basic discovery layer, we do also need repositories of semantic artifacts, and we need to understand how these different ontologies are being governed and maintained and updated. And in terms of the licensing and the legal aspects, we call for standard human and machine readable licenses. We want permissive licenses, particularly for the metadata to aid the discovery, but ideally for the objects themselves as well. And in this context, CC0 is preferred over CC BY. So to dig in a little bit on the semantic interoperability implementation, there are a few layers to this. Obviously, we need the metadata catalog and the crosswalk so that we can have this common search. But we also need semantic artifact catalogs. We need to understand the different ontologies and what's meant by those different terms that are being used. And critical to this is the mapping repository so that we understand, one standard and how it aligns with another. Within the interoperability framework, there's a semantic use case that's presented, and I just wanted to provide that to you here. So a rare disease researcher, for example, is seeking clinical data, and they want to ensure that that data matches the current study population and the variables that are being interrogated. What they're trying to do is reach a population size that's needed, so increasing the size of the cohort. So they can search the metadata catalog to find candidate datasets, but then they need to go beyond that basic discovery layer, and they need to search semantic artifacts, which are based on the different domain metadata schema to check whether the relevant variables are present, and if so, then they can include those in their search. So this is how they're agreeing a subset of data to reuse and to bring all that together within the EOS context. As I mentioned before, the FAIR and Architecture Working Group started a basic metadata mapping. So this was looking at the common kind of discovery standards that are used, like Dublin Core, schema.org, DCAT, DDI, and they've proposed some mandatory and optional elements that can help us with FAIR digital objects. You can see the mandatory elements are very minimal here. So obviously we need persistent identifiers. We need the basic metadata that lets us know who's created the resource, what it is, when it was published, the resource type, and the licensing conditions, so we know how that can be reused. And then there are a number of optional elements as well. And one thing I'd like to stress here is that we're really focusing on developing crosswalks, not developing a new standard. We realize that there are lots of existing standards in use by the research communities, and we want to support their use within the EOS context. So really we need to map between them all rather than implementing anything new that adds a burden to the research groups. This was a key lesson from the EOS pilot project. They had tried to specify minimum information for EOS datasets, but there was quite a pushback from the community. Now, what we've done here, this mapping is very preliminary. This is not an end result. There needs to be a concerted piece of work to develop this further and to do a lot of consultation with the research communities. And that's something that will happen under the next round of EOS projects that are just getting started in the coming months. I did want to show one example of how this has already been done, though, on previous projects. The IVOA, the Virtual Observatory in Astronomy, has been integrated into the UDAT V2Find service. So what they've done is they've exposed their VO data using OAI-PMH as a protocol to pull that out, and the Dublin Core standard, so that they were able to be integrated into this common search in V2Find, which is a kind of repository and discovery layer that UDAT offers. And then you can see there's various kind of keywords and publishers and resource types that are focused on the astronomy community. So there's a disciplinary extension to that metadata schema that's based on the astronomy standards and data. So this is the kind of model that needs to be taken further within EOS to enable that kind of search and discovery that we're hoping for. So the next step then is implementing this into the EOSC portal. The portal is the main catalogue and marketplace where researchers can discover services and data sets. And we'll be taking all of the work that's gone on in previous projects and through the EOSC Interoperability Framework and implementing that within the portal. And the next project that's coming up, which will be addressing this, is EOSC Future. This is a multi-million euro investment with several partners. It brings together all of the e-infrastructures and the research infrastructures, and it will be addressing that discovery, but also the composability of resources. So enabling people to bring together all of the relevant data sets with the services they need to act on those. And there are different aspects of composability that will be addressed. It may be that, you know, a service provider wants to integrate with the common federated AAI to enable easy log-on to multiple services and not requiring researchers to use different mechanisms for access. Or what's of more interest is this kind of D arrow here, the composability and bringing together of data between different research clusters or communities. Now, this has happened within research clusters, that they've integrated data sets from different research fields, but cross-community is where we really need to enable that to address some of those societal challenges. So there are a number of science projects that will be worked on addressing key concerns like aging population, climate change, and smart cities, and the COVID pandemic. And that's where we'll be looking to enable that metadata exchange. Now, I mentioned this this project is still to begin, and I mentioned this now because within the EOS context, there's some basic discovery, but I think this ability to map between the different units and the values is a much bigger challenge, and it's something that really we're only just making a start on now. So that's a summary of what's been done within the EOS context and what's coming. Thank you very much for your attention.
We are going to make discussions, and Mr. Carrion, there is some questions from the audience to the speakers. Mr. Hajdu and Mr. Kai will answer for the first paper, the first presentation of the paper, this presentation of Simon Cox, and Mrs. Jones will answer about his presentation.
I think there's one by Luca Mari about the metadata and that FAIR's 90% metadata and the novelties of FAIR. I can maybe give an initial answer to that if you like.
Yes, I think it's good. Yeah. And I asked the audience to put your questions for the speakers on the chat. Yeah, of course. Okay. So in response to Luca, yeah, FAIR's very much predominantly focused on the metadata. I think one thing that makes it a novelty is just how well they've articulated the needs there, and that it's a very catchy concept. So it's been picked up a lot in policies and is then being iterated through initiatives like the EOSC. Also, there's a strong focus in FAIR on machine readable metadata. So making sure the standards are well documented and that we can, we can use that metadata well, and also to promote crosswalks between the different standards, which is certainly the emphasis that we're taking in EOSC. So I think, having good metadata is the core, but then what we can actually do with it and making sure it's well defined and reusable is I guess what FAIR's adding.
If I could just jump in and add one little point there.
Yes.
Yeah, so I thank you. I would agree with that answer. And I would just like to say one thing, that in one way, interoperability could be thought of as where does my vocab go from here? In a sense, you know, if an ontology or a vocabulary actually does link to other existing resources, it makes it machine interoperable with those resources. If a vocabulary is kind of in its own and is kind of a silo or a dead end, it might not necessarily be as interoperable with anything else. So I think that's one of the key takeaways from FAIR from my perspective.
Okay, there is a question here of where Diego Copa, are the projects within EOSC in order to achieve all the recommendations that Sarah gave? Thank you, Diego. Could you answer this question, Ms. Sarah Jones?
Can you hear me now?
Yes.
Yeah.
Yes. Okay. Sorry, my screen just froze then. So so within the EOSC, I wouldn't necessarily point to one project that's implementing all the recommendations, because the EOSC is about federating the different research infrastructures. But certainly within the different S3 projects, they have already been working on ensuring that data can be exchanged between the different communities within their clusters. So I think there's already examples there, or like the IVO example that I shared, that show work towards that, but they're still kind of being brought into EOSC and onboarded into the infrastructure there.
Okay, there is another question here from Nemad Ivesic. Is there a practice, state of practice and art report on interoperability solutions that the community is referencing? There is no indication for whom to speak. Ms. Haju, could you answer this question?
Difficult question, interesting question. I would like to ask that question myself. Yeah, sorry, it's a very good question. I don't have an answer.
I think the Go Fair, Force 11 and Go Fair have some links off to a variety of collections of resources and documentation about how fair they are. So I think that might be a place to start. Let me see if I can find a link for that.
Thanks.
Mr. Hector asked a question for Sarah, from Mrs. Jones. Up to now, did you experience problems with the expression of measurements results in the EOSC?
So I would say that hasn't really been a focus within EOSC just yet. The kind of first step is federating the different research infrastructures. And the focus has been on the kind of discovery layer of metadata. So it hasn't really dug down as deep as the measurement of units. But certainly within the individual research communities, that has been a priority and things they've been working on. So I think that will come in EOSC, but in later stages, it hasn't been one of the areas that we've been focusing on just yet.
Thanks. Let me see if there is another question here. Hugo Gasca, among the different options for implementing FAIR concepts such as several ontologies, is there an effort to standardize it or unifying them from the perspective of BIPM? Mr. Kai, could you answer this question?
Sorry, from the perspective of
The IPM, the organization. Yeah. I can't answer this question. Anyone else? Well, once again, I can only say that this is a very interesting question. I would like to ask that question too. I've been wondering why, for example, unit of measure ontologies, had to be developed by well, non-standardization organizations. I've often wondered that. So yeah, sorry for my answer. That again, I think the question is very interesting. Maybe someone from BIPM could answer that, but.
I think there may have been an example in Simon Cox's talk as well about trying to unify the units of measurement across the different standards and examples he gave.
Yeah, but
right.
Not, sorry.
No, absolutely. And Heo and I are, and Simon and many of us are working to that front. But I think specifically the question was about BIPM and their role in this, and it's still a little unclear.
Exactly.
To what extent they are participating in
and
such
another
efforts.
Standardization board like ISO, it's possible they make it this kind of a standard.
Sorry, I don't understand what you mean.
There is not only BIPM, but there is other standardization bodies like ISO.
Yeah, like ISO. Yeah. Well, yeah. As far as I know, they are not busy with creating an ontology of units of measure and related concepts. And once again, it has always wondered. I've always wondered why. Well, why not actually? Yeah. So. Yeah, and Kai and me and Simon and other people are involved in trying to see whether the existing approaches can be related to each other or aligned. But once again, that's more because we really like it, all of us, than some guidance or question or demand from some organization, as far as I know.
Yeah, I just noticed there's a couple of comments from Simon Hodson in response to this and the messages. I don't know if everyone can see all the panels, but just saying that the digital system, digital SI is part of that, and the BIPM's major contribution can precisely be in the digital SI. Digital
SI. Okay. For the first time that I hear about the digital SI, that sounds great. Are they developing an ontology of units of measure? Is that the digital? Oh no.
I'm not familiar. I don't know if Simon Hodson's able to speak up or not.
Yeah. Okay. And there was an interesting statement. I think that it was in your presentation. Maybe it's also interesting with regard to unit of measure ontologies. Should there be one overarching standard, or will you then end up with some new standard? I think that's a very interesting question. I think I don't know what to do.
But emphasizing though, Dr. Cox's point was that as long as we're building bridges between any used existing systems, that can help to overcome the cultural and historic backgrounds of the different use cases and invested infrastructure and why different groups of people use different systems. So I think I'm just trying to channel my inner Simon Cox, but I think he would say, as he did in his presentation and earlier in the questions session this morning, that as long as we're working toward bridging things, we are helping to bring together that which might seem separate on the outside. But as long as it's bridged, then we don't have to have one system, and it might not be helpful to have one system at the end of the day.
Okay. Okay.
That's I don't know. I always have this view that in the end, in the world, we should end up with one ontology of units of measure. maybe because I believe that the quality will be better or something like that. I don't know. But let's start with bridging. That's definitely a very good start.
But
yeah.
But it's necessary. So
Oops.
Okay. Okay, we have another question from Francisco. For the panel, we have a K-Bloomberg digital unit or FAIR implementing SARA Interoperability Framework.
That's not a question.
Maybe I can insert some comments here, because as Simon Cox demonstrated in his presentation, there are a number of these systems for representation of units that are well established in various communities. And when the Digital SI expert group was formed, the first question that we debated is whether under the CIPM and BIPM we should try to come up with one overarching system or whether we should embrace the fact that these already exist. And we took the latter approach because you're not going to, I don't think BIPM and CIPM are going to tell the biomedical community to stop using UCUM. It's well established. So we need to build the bridges first. And then if a clear winner emerges from amongst those systems, we can embrace it. But we felt in the expert group that this is, it's better to start by bridge building rather than trying to build an entirely new infrastructure.
Yeah. Yeah, I have the feeling that if like BIPM would create one new overarching ontology, yeah, it would have more authority, I think, and for all, maybe in the existing situations where some ontology is used, okay, they won't switch to a new ontology, maybe, perhaps, I don't know, maybe they will. And many new users, I think, would try to find an ontology within the ISO or BIPM organizations, I think. So yeah, okay, maybe let's summarize what I'm saying to BIPM and ISO have authority, and that's that should be the reason why they should develop such an ontology. It's a statement. Anyone can shoot at this statement, of course. Yeah, wouldn't you think? What would you think about what I'm saying about the authority that BIPM has?
I would say I agree with you, but having authority doesn't necessarily mean that everybody will follow your rules. So. Well,
yeah, okay. Not only authority, but also, as a result of that, I think, popularity. I mean, one of the first parties or stake, you will turn to when you need ontologies of units of measure are the standardization organizations, I think. So it's not only authority. Yeah, it's not only authority, but also that it's the first obvious choice to look for such an ontology. So yeah, that's even more than authority, I think. Yeah.
It's also a much heavier lift to come up with a new scheme that encompasses all of the existing practice rather than build the bridges between those that exist. So there's a resource challenge as well.
Yeah.
And that's, again, another reason that so far we've adopted this bridge building perspective. I see Alan Steele has made an extensive comment here that I hope people can see.
I don't see, I have to go up. Oh, it's long. Okay, I have to read. It will take a while.
I can just respond quickly to, I saw there was a comment considering the relatively new SI redefinition 2019. Would I have any perspectives for a new digital SI release? I think it's kind of relevant to this. I think all of the different systems can, in their own way, take into consideration the new SI, the changes made to it. But again, I think the discussion really is about whether or not we're taking more bridging type system. I think I'm actually more now in agreement with Dr. Cox than Dr. Riesberg, that we should be focused on the bridge building because there are just very different user communities and stakeholders involved for each system. So I think unfortunately, I guess everyone might have to kind of take in those new changes themselves, although it doesn't necessarily affect the implementation too much just because the constant changed for how we redefine the base SI units. We can update those in existing ontologies.
Yeah, I agree. Like Robert said, if there are no resources within BIPM or ISO to create an ontology of units of measure, we have to do something else. Like building the bridges, that's the best thing we can do then, I think. So, in fact, I agree with that. Maybe one thing I would like to ask, wouldn't it be possible to raise funds, or am I saying something very something very crazy?
We should ask Martin Milton that when he speaks to see if it's feasible to do that. Right now, the Digital SI initiative is being marshaled from existing resources at several NMIs. And I think if we were to consider a much bigger push on this, we'd be talking about dedicating some tens or 20s of people to work on it. So I'm not saying it's not a valuable thing, but I saw a question, what did I mean by bridge building? I mean building interoperability layers that allow you to easily interpret and translate between different representation systems. And we're already doing some work in that regard at NIST and with my collaborator, Stuart Chalk. But so that's the approach that we've been advocating at this point in time, given the resource requirements of coming up with something totally new.
Yep. And I also see this question of Alexis. We didn't answer that one, right? The question, he said, or she maybe, the question is if the digital SI will be able to provide this unique overarching system. I'm not familiar with digital SI. It sounds digital, of course, but is it an ontology?
The digital SI is not only talking about how to represent units of measure and establish traceability to the core SI. It's also about turning the other assets to do with metrology, such as the International Vocabulary of Metrology, the VIM, and the Guide to Uncertainty Measurement, the GUM, into fully digital, fully machine readable documents, entities. So it's a suite of activities. In this workshop, some of that will come to light. A lot of the focus, however, is on representation of units of measure, such that data, once they are found, can be made interoperable and reusable in the context of FAIR, and to assure that units of measure are being interpreted correctly and unambiguously.
Yeah, you're saying, do I understand correctly, that units of measure are being made machine operatable, readable?
Right.
So
that's part of our goal.
That's through an ontology then. That means through an ontology.
That means being able to ingest the various systems that Simon Cox talked about into a basically a web service that supports interpretation, expression, and conversion.
Yeah. Okay, yeah. And how will that system, maybe too detailed question, but how will that system deal with, well, like the meter defined in the one ontology and the meter defined in the other ontology? Will it simply merge these definitions with, or
no, the current thinking is it would retain the definitions in each system, and a user of this platform would say, okay, I'm working in QUDT, and I would like to make sure I'm expressing the units of measure in my research paper or in my data set in the proper QUDT representation. Or I might say, I have a data set in which the units are represented in UCUM, but I would like to see them represented in QUDT because that's where I'm working. So you could submit a data set to a service, and the response would be that same data set, but with the metadata describing the measurands and their associated units in the system that you're working with.
Yeah. Okay. You could use the work of Simon, I think.
Oh yes, he's involved. He's a member
He's involved.
of the expert group.
Yeah.
And also of this CODATA task group on digital representation of units of measure that I happen to chair as well. So I wear a couple of hats myself in this.
Yeah, interesting. Nice to hear about that. Yeah. Let's see, do we have some more questions?
Okay. There are two more questions, but the time ends, finished. I would consider this section closed, and I would like to thank the presentations, Mrs. Sarah, Mrs. Hayo, and Mr. Kai, and also the ones who requested the presentations. Okay, and to now there will be a break, and after, let me see what time. The session will be open again to the second part of this day. Okay, thank you everybody. Thank you the audience and the questions that was sent to the presenters. Thank you.
Thank you all.
Thanks. Bye-bye.
Yeah.